Assalamu alaikum, bismillahirrahmanirrahim. We are discussing MPLS. Our course was Service Provider Routing and Switching Specialist, JNCIS-SP. Last class, we discussed RSVP Constant Shortest Path Fast, CSPF, and the admin groups. Today, we discuss RSVP, LSP failures, errors, and session maintenance. Okay, so it's very short duration class. So let's start. Only two sections here. Number one is RSVP masses. That is masses including path error masses, receipt TR masses, path TR masses, and receipt error masses. TR and error masses. Consider RSVP overload reduction extension. Okay, so let's start. First part, RSVP masses. There are four type masses communicate in RSVP neighbor, path tier, RSVP recipient, RESP recipient, path tier, and receiver. Tier and error. Okay, so this is the terminology of and acronyms of MPLS network. So first one is RSVP fail. RSVP failure. When we get any failure, it can be for link down, or it can be from router down or protocol itself. Okay, so here we discuss RSVP failures, problems, and errors. So first message is tier, that means path tier and receipt tier. Basically, it is used to tear down an LSP. Path error and receive error used to communicate, note out the errors and information. May be used if an LSP cannot come up in the first place. May be used when an LSP is already up, but something changes. So this is the event. You can get error in your LSP path. Okay. So commonly RSVP tier and path errors sent at the same time. One tears down the LSP and the other says why. Just one sending the masses and other one just query the masses. That's called why. So see the topology here. Link is down. Link is down. So we are getting RSVP tier and receive tier masses from router 3 to router 1. And path tier masses to egress point. This is the ingress point, and this is breakpoint to egress point. That is path tier masses. Okay, this is left side, that is ingress router, breakpoint to ingress router. We are getting receive tier masses, and from breakpoint to egress point, we are getting path tier masses. Okay, so here path tier and receive tier masses. This is the diagram. Blue LSP. This is the blue LSP. From router 1 to router 5. So router 1 is the ingress point and router 5 is considering the egress point. So this is the shortest path calculating from IGP. So when router 3 to router 4 link goes down, then what happened basically? So see the process or step. Number one, what happens if the R3 R4 link fails? Failure notified by ISIS or OSPF or DFT or by the physical interface going down. Can get messages through the protocol. Also, you can get information from physical interface. Router 4 sends a path tier to router 5. Router 4 sends the path tier to router 5, but router 3 sends receive tier 2, router 3 sends receive tier 2, router 2, and R2 sends receive tier 2, router 1. That is, R2 carry forward the receive tier message to router 1. So in left side, sending receive tier, and in right side, message sending, the message name is path tier. That's the difference. Okay. Path tier and receive tier message contents. This is the snap from Vashak. See the content, which content is included here. This is the RSVP header, message ID, and this is receive tier message, and this is the destination. 105 is the destination, and others one is session object, tunnel ID, others information. Okay, so this is basically resource reservation protocol, RSVP, tier message, and tier message contain this type of field. Here you can get the destination, you can get tunnel information. Okay. Path tier and receive tier message contains message ID, that is 41, acknowledge digit. The session object identifies the LSP to be turned down. The tunnel ID is 41127. The tunnel ID combined with the LSP ID uniquely identifies the level switch path. Okay. Okay, then control plan downtime when an LSP fails. So what is the control plan downtime? A receptor does not arrive at router 1 instantly. Okay, router 3 sent to router 2, router 2 receive this message and again send to router 1. So receptor does not arrive at router 1 instantly. Downtime while the message travels to router 1, R1 keeps forwarding traffic down the LSP. R3 will have to drop the packets. In that time, router 1 sending the packet are to drop this packet because they already know link was down. Okay. So downtime while R1 reacts, R1 has to process the message, R1 has to calculate and signal a new path. New path, that means alternative base path. You can go alternative base path through router 1 to 6, then 8, then 9, then router 4, then 5. It can be. Okay. So need to calculate the new path. R1 has to install it in the forwarding table, and this path is installed in forwarding table. The more LSP, the longer this takes, the longer it takes, the longer the time. So it depends on the time to recalculate the new path and install this path in forwarding table. So this is the total timer when one link goes down. LSP will take this time. Okay. Avoiding and limiting LSP downtime. If you want to avoid and limiting LSP downtime, so here is the local repair path from router 2, router 4, used if a fault occurs at router 3, considering here, SPOF can generate a local repair path. Okay, that is alternative path or repair path. So how to do this? Downtime can be significantly reduced. If I make this downtime significantly reduced, create backup local repair LSP. Need to create backup local repair LSP, pre-signal to route around links or nodes. Create secondary path for an LSP at the head-end. Head-end, our router 1 is the head-end router and router 5 is the tail-end router. So if I make the backup path under the LSP in router 1, so your local repair time or downtime will be reduced automatically. Okay. So create secondary path for an LSP at the head-in can have different constraint to the primary and be pre-signal for immediate use. So both of these mechanics make use of path error masses. Both mechanism use path error masses. RSVP primary and secondary path you have to mention. RSVP local repair, one-to-one backup or fast reroute. You have to enable fast reroute. RSVP local repair part to facilitate backup or node link protection. So if I enable fast reroute and mentioning the primary and secondary path, it will reduce the downtime. Okay. RSVP path error and receive error messages. So first one we discuss path tier and receive tier messages. Now we discuss path error and receive error messages. So path error and receive error don't tear down LSP. Basically, don't tear down LSP. They just report errors using new error object. They're just tracking the error and sending it's a new error object as a new error object. Errors in response to path messages, bandwidth reservation that cannot be honored, straight hops that cannot be honored, unknown loose hops, empty problems, RRO that contain a routing loop. Means your desired destination path goes down and they are making this problem basically. Error once an LSP is already up, link down, but the node closest to the fault has backup path. Link down, there is no backup path. So basically they are generating the error masses and sending as an object to the nearest router to acknowledge this. So consider one, this is the path error message and this is the receive error message. So path error message I'm getting the head in and receive error message I'm getting in the tail end. Okay. So the direction of path error and receive error message. This is the direction basically. So path error and receive error travel in different direction to other messages. Path error travels from the problem to the head-in router. That is problem to the upstream router, you can say, or receive error message is problem to the egress router or downstream router. Okay, so this is the direction basically. Path error packet capture. This is the WhatsApp packet capture of path error messages. Path error messages contain the object class error object as an object. They are sending messages as an object error message. Error code, routing error, error value no route available towards the destination because your link goes down. They're not getting the available route in your route table. That cause this error. So after this section, now we are in Q&A section. So number one question, identify the purpose of the messages that deal with RSVP failures, problems, and errors. So here we see four type of messages: path tier, receive tier, path error, and receive error messages. So path tier messages used to tear down an LSP and are sent toward the egress router. And receive tier is ingress router, problem to ingress router. Path error and receive error used to communicate, note out the errors and information. Number two, what are the masses that collectively deal with RSVP problems and errors of different kinds? Path error and receive tier. What can the path error masses indicate if an LSP fails to be established? That can be unknown loose hopes, empty problems, RRO that contain a routing loop, multiple region. Is that multiple region except including link down, including link down. Okay. So we're now in second section, RSVP overload reduction extension. How to RSVP overload reduce the time error is the terminology and acronyms of our MPLS. So RSVP was originally a soft start protocol, basically. Okay. So this is the MPLS router where we enable RSVP. So how are RSVP session maintained? So original protocol was soft start, no adjacency, no acknowledgement. Refresh message sent every 30 seconds for its individual LSP. Unacknowledged, send them and hope they are received. Path tier, receipt tier only sent once. If it was not received, routers had to wait for LSP to timeout before the resource was freed. So here, basically, the freezer of RSVP, sub-state protocol, and their adjacency and message communication information. So, RSVP sub-state customization. We can customize the timer, RSVP timer, message timer. The old version of RSVP, some things are customized, like 30-second refresh time, customizable with the refresh time statement. If you want to modify the refresh time, you can set here. 3 message limit, customizable with the keep multiplier statement, and rarely changed in production. OSPF ISIS PFD detect problems for quicker. If we use OSPF ISIS, including BFD, that's failure detection time automatically reduced. So in that condition, you no need to change the refresh time or keep multiplier. You can keep it default, no issue. Okay. RSVP was enhanced to reduce overhead. How? In RFC 2961, RSVP refresh overhead reduction extension. Big improvement is here. Okay. New bit added to the RSVP header. The refresh reduction capable bit indicates support for 3 features. There are 3 features after extension RSVP in RFC 2961. RSVP bundle message send more than one message in an RSVP packet. In previous or old version, only send a single message. Message IDs and acknowledgement makes RSVP reliable. Message ID and acknowledgement. Summary refresh extension or S refresh message. List multiple LSP to refresh in one single refresh message. So 3 messages included in enhancement. So if you just verify the RSVP overhead reduction, show RSVP neighbor detail, you will get refresh reduction. Refresh reduction, that is operation. Okay. Enabling RSVP overhead reduction on all Junos before 16.1. 16.1. For earlier version of Junos, add this statement when interface aggregate. Set protocol RSVP interface aggregate. So enable message bundling and summary refresh. Aggregate will make this. If we set reliable, enable message ID and reliable acknowledgements. So if I set both keyword aggregate and reliable in RSVP participator interfaces, we'll get extension 3 messages. Okay. So let's see our lab. The next one. Shows. root password is 3. Edit. So edit protocol RSVP. So set protocols RSVP, then interface. Interface is ZE-0 and see here the aggregate. Permit refresh reduction extension of the interface aggregate. And another one is reliable. Permit reliable message delivery on the interface. Okay. You can set this. If your voice version under 16.1 transfer version, I'm using 14.1. That's why I'm just manually adding this one, aggregate and reliable. Okay, then RSVP hello message. RSVP hello message. RSVP hello message are optional. Default is 9 seconds. They're sending hello message. The interval is 9 seconds. LSP will be turned down if hello messages are no longer received. Customize RSVP hello packets on a per interface basis using hello interval configuration statement. If you want to change hello interval, you can change this one. So after the interface, the hello interval, this is the value or range of hello interval 0 to 60, you can set. Use this configuration to change the hello interval. Some vendors might not send hello message at all. Junos reverts to the sub-distant version of RSVP in this case. Normally, need to change the hello interval. You can keep it default. Okay. So if you want to change actually, so command will be interface, then hello interval. This is the hello interval range, hello interval is 0 to 60. So default is 9 seconds. You can set different hello interval. Okay, then our Q&A section. Question 1, how can you maintain RSVP session using a soft distant protocol and with refresh message sent every 30 seconds? Identify the features supported by a router when a new bit is added to the RSVP header. So in RSVP bundle message, enable a router to bundle multiple RSVP messages into one single PD. And another message is message ID and message ID acknowledgement. Include the object in RSVP message and trans RSVP into a reliable protocol. Summary refresh extension refreshes the RSVP state without having to send enter path and receive messages. So this is end for this topic. So today we have finished our module. So next class we will discuss module 12 RSVP primary and secondary path. That will be more interesting. Okay, thank you very much. Allah Hafiz.